As Susan said, I am here to provide a bit of background on a major new project that the University of Oklahoma, Oklahoma State, and a number of other universities have taken on in the state. Susan, if you'll enable the screen sharing, I can show people some graphics that might help with the description of this project. Okay, I am hoping that everyone can see this. The project that I'm describing is called the Socially Sustainable Solutions for Water, Carbon, and Infrastructure Resilience in Oklahoma. The shorthand, which you have to have for any large-scale proposal like this anymore, is S3OK. You can see on the slide there some of the entities that are participating in this: OSU, University of Oklahoma, the Noble Research Institute, Southwestern Oklahoma State University, ECU. Susan Paddock has a leading role in this project. The University of Tulsa and Langston University are all participating. All of these groups have researchers that are part of this investigation. The money comes from the National Science Foundation. They provided a $20 million grant that lasts 5 years. This comes under the heading of the EPSCoR program, and this is the established program for building new research capacity in states like Oklahoma. It encourages the collaboration across research institutions to try to enhance our educational and research missions. The grand challenge for this project is to find what will be broadly acceptable and sustainable solutions in Oklahoma to a set of wicked problems that stem from 4 sources. One is changing seasonal and subseasonal weather extremes. The second is terrestrial water and carbon dynamics. Many of you will know that this has to do with how we manage our land surface, our soils, and how woody plant growth develops. Another has to do with changing water quality and quantity. They're shifting as the landscape use shifts in Oklahoma. And all of these contribute to enhanced threats to infrastructure in the state. So these kinds of problems lead to the focus of our research. But before I get to the science itself, I need to get to this question of wicked problems. It's a sort of a strange term, but wicked problems are those that are difficult to solve because of incomplete or contradictory knowledge, divergent interpretations by different groups, and because they tend to be interwoven across multiple problem domains. That makes them extraordinarily difficult to get a grip on. Now, wicked problems typically consist of bundles of threats and presumed solutions that take the form of competing arguments, stories, or maybe even narratives that we use in society to address those problems and think about how to solve them. Let me give you an example from a different domain, and that has to do with vaccines. So, as you know, when we address the vaccine problem in the United States, you could see it as a public health triumph that's resulted in millions of saved lives through the result of through the advancement of science and understanding of public health. Or it could be understood as a government-imposed risk, that is mandatory vaccines that harm children and that primarily benefits big drug companies. Now, those are 2 competing stories or narratives that focus on a common set of threats and proposed solutions. And wicked problems take that form, where there are quite different notions about how to understand a threat, who is harmed, who is benefiting. So competing wicked problem narratives tend to result in polarized views and policy gridlock. And everybody here is familiar with how that works. It's playing out in many domains across our society and the world now. The S3OK effort is to develop and test science-based solutions for wicked problems that are at the intersection of these seasonal to subseasonal weather changes, variable to marginal quality water, terrestrial water carbon dynamics, and sustainable infrastructure. What we want to do in this project is identify sustainable solutions that cut across the usual competing wicked problem narratives that frame the social conflict that we address. We would like Oklahoma to be able to lead the way in coming up with reasonable, sustainable solutions to these problems. So the way we think about this, the framework, looking at this circle on the left-hand side of your screen, we start with those narratives, the claims that are being made, the way that sets of impacts on the Oklahoma public, industry, and ranching and farming are affecting the way we understand the world. Those narratives shape the set of wicked problems that have to do with the intersection of these four problem domains that I've been mentioning. The S3OK is going to set up a series of engagement dynamics between scientists, the broader science community, and the specific science teams that are going to be working on this problem. A panel of opinion leaders that we will call the OLAN. I will talk specifically about that in a minute because I'm hoping that some of you might be willing to volunteer to participate in that. And an array of Oklahoma households. So the engagement process is going to be taking the science that's developed in response to concerns in Oklahoma and evolving it over a 5-year period to look for solutions that are sustainable for people who might have very different views about how the world works. We're not trying to change people's values or fundamental beliefs. We're simply looking for problem solutions that can address the impacts that are being felt in Oklahoma that are sustainable. So let me give you an example of a wicked problem that will be one highlighted in our project. We'll have a set of 4 or 5 wicked problems that all have to do with these overlapping areas. But the one I want to draw your attention to at the moment is called weather whiplash. So in the study of Oklahoma weather pattern changes, we are observing more rapid swings from periods of flooding to drought. These are from extreme to extreme. So we're sandwiching together these periods of pluvial, what are called pluvial events, where we'll get multiple inches of rain in a very short period of time, to flash drought. And we've been able to track over time the increasing frequency of these and severity of these events. And the consequences are billions of dollars of losses, flooded streets and communities, low water supplies during one period, followed by a superabundance in a later one, dried up crops, imposition of water use restrictions, and more specifically, the heavy rains in the pluvial periods can overwhelm our drainage and wastewater infrastructures, resulting in excessive runoff from the impervious surfaces in urban areas in particular, or from agricultural fields. The runoff carries contaminants which pose potential health impacts downstream, but which may not be measured or even fully filtered from drinking water systems. So we have these rising concerns about the way that water quality is affected downstream because of these surges in water. I would add here that we also have problems with water storage. When we have these floods followed by droughts, you get a whole lot more sedimentation taking place in water storage systems. So the capacity of our reservoirs is diminished more rapidly because of these events. So our existing water diversion and storage infrastructure simply hasn't been designed to handle these extreme loads and the rapidity with which they occur. And that's raising costs, damaging infrastructure, requiring that we rethink how it's built, all the while imposing substantial costs on Oklahoma communities. So these weather whiplash events are, again, very costly. They affect many Oklahomans, and they require thinking about problems a bit differently than we have in the past. But the thing is, these weather whiplash events, we all perceive them, but we put them into different stories. So here's one narrative about these whiplash events that I'd like to draw to your attention. And this one would basically argue that nature is relatively robust. It isn't going to respond dramatically to human interventions, and it's unlikely to be much different in the future than it has been in the past. So this whole notion of weather whiplash is likely to diminish as weather returns to a more normal pattern in the future. So contextually, when you think about nature that way, weather whiplash is an anomaly, not something that we need to concern ourselves with over the long haul. That means that worries about increasing disasters resulting from a warming climate are really overblown. The responsibility for assuring that households and communities are resilient to these kinds of things by this narrative should fall on those who are most affected. That would be the individuals or the householders, and perhaps local governments that have to manage these events. But it's not really something that all the rest of us need to be very concerned about. Businesses and households can be trusted to understand and to pursue their own interests. And private markets are better able to respond to changing household and community needs than are governments or large-scale programs. So the whole idea of relying more on regulation or taxes and big programs are bound to waste money, especially since those impacts are just temporary, being that this is more likely an anomaly than a real trend. So what I want you to see here is that the events that we observe, the actual observable impacts of these increasing weather whiplash events can be fitted into a way of understanding the world that makes the story take a particular tone. Here's a second narrative that treats it quite differently. The second narrative would argue that the increasing effects of whiplash are the direct result of human-caused greenhouse gas emissions, and therefore we should think about this as part of a trend. You see this narrative a lot in the mainstream media and other places. If that's the case, then we can expect these trends to worsen considerably. The problem is, according to this narrative, that those with a financial interest in continuing modern industrial and social practices have sought to influence science and public debate to delay the recognition of the problem. So you weave into the story not only expectations about the future trend, but also who's to blame, right? So narratives do that. They link problems with victims, with those who are responsible for causing the problem. By this narrative, the impacts of weather whiplash fall disproportionately on the poor and the underrepresented communities, those with less capable infrastructures for handling these kinds of problems. And we need to act now in anticipation of worsening impacts on those and other communities. All of this narrative leads you to the idea that we need aggressive government programs to address the larger problem of global climate change by reducing greenhouse gas emissions and shoring up community resilience, because by this narrative, those problems are inextricably entangled, and we can't deal with one without dealing with the other. Now, the reason I'm telling you this is not because either of these are true. They are simply different ways of piecing together what's happening with an underlying set of values and beliefs and notions about who is responsible and who's going to be harmed. And when you do that, when you connect the empirical understanding of a problem with these underlying values and norms, you create these wicked problem narratives that make it extremely difficult for people to talk to one another. Because there's too much that's already entwined to disentangle the conversation to deal with those kinds of things that we can all agree on. So how are we going to address this? Well, the first step is the science. So we have science teams, networked science teams that are going to work on 5 different domains. The first has to do with the social dynamics. This is focusing on the societal response to wicked problems, the pursuit of socially sustainable solutions. That's going to be coupled with a second team that's going to focus on these seasonal to subseasonal weather extremes. So these are some of the world's very best meteorologists and climate researchers who will be looking at these trends, understanding why we would expect to see these extremes occur, linking them to events so that we can, in fact, perhaps predict them better. That group will be providing inputs to the terrestrial water carbon dynamics team. These are the people who are going to be looking at the interaction of land management, water, soil, and flora. One of the things that this group will be dealing with is wildfires. So we know that pluvial events lead to woody plant growth in Oklahoma. A lot of these are invasive species and carry an enormous amount of fuel load, followed by a flash drought. The development of these fuels can lead to conditions that are ripe for serious wildfires. We're seeing this happen across the United States, but these kinds of dynamics that come from seasonal to seasonal weather patterns lead to these water carbon dynamics on the Earth's surface that have real implications for our communities and the safety of our populations. That group will be working on that, on issues of protection of the quality of the soil in Oklahoma, the way we manage those lands, invasive species, and a variety of other factors that are linking this process to wicked problems. The next team is the variable marginal quality water team. This team will be focusing on the increasingly variable and marginal quality water that's available to Oklahoma and the implications for how we work on providing sustainable water supplies that are appropriate to the end use. A lot of this team is going to be focusing on the way that filtration happens, both naturally and with infrastructure systems to assure that water is available. They'll also consider water storage. When we have huge gluts of water followed by absence of water, it does force you to consider how to manage storage in a way that is sustainable and also serves the various end users in the state. All of those are driving infrastructure, right? So all of these other changes force us to think about the effects on water, transport, energy infrastructures, and the future requirements that are going to be there. So as you can see, these are linked. The little diagram on the right-hand side is showing you the networked nature of our teams. Every team has scientists from at least one or at least two of these areas, and in many cases, three or more. These researchers come from across the spectrum of universities in Oklahoma. And so I'm particularly excited about the advancing understanding of these problems. But we know that looking at these problems purely from a scientific perspective isn't going to be able to address wicked problems. So we've assembled a program design that links the science areas, that's in that blue pie that you see there. They're going to have a large group of an extended peer science advisory network to advise all of those teams. But the critical piece is going to be input and feedback, from Oklahomans. The OLAN is the Opinion Leader Advisory Network. This is going to be a group of people who have been in positions of significant importance in Oklahoma, who are opinion leaders for either subgroups or across the state, who understand what's happening in the different sectors of Oklahoma from the perspective of Oklahoma stakeholders, who can advise the science teams. So the science teams may have a sense of what it is that's going on and what matters, but the OLAN is going to provide a much clearer sense to each of those science teams about what it is that matters to Oklahomans and how it's understood. There will be interaction between the Opinion Leader Advisory Network and the science teams, so that the science teams will be informing the OLAN and the other way around. And in fact, the OLAN is going to have considerable teeth in this process, in that there are going to be resource changes made over the course of the project, so that promising projects can receive additional resources. And the OLAN is going to be a big piece of informing the leadership in the S3OK program about where those reallocations ought to be made. Now, all of this happens over 5 years, as you can see from the little diagram there. So that year one will essentially be setting up and understanding what the key implications are for Oklahomans and how those are woven into narratives, how those narratives are should be informing the way research goes to help Oklahomans better understand those problems, to figure out potential solutions that may work for multiple groups and fit into multiple narratives. We'll be repeating that over the 5-year period. So we'll be learning from each year and iterating between the opinion leader group, Oklahoma residents more broadly, and those science groups to reach by year 5 a joint plan that details sustainable solutions for Oklahoma in these areas. We think of this as essentially a book that we're going to be jointly writing between the scientists and the OLAN members that will lay out a way forward for Oklahoma in dealing with some of these wicked problems. So the advisory network recognizes at the outset that science alone isn't enough. You can't solve these kinds of problems without collaboration amongst science communities, state leaders from many sectors, and taking into account the perspectives of the broader public. The OLAN is going to be drawn from those leaders statewide. And it will play, the OLAN itself will play at least 4 critical roles in the project. Now, these are going to be subject to change because as we learn, we're going to improve. But the first is going to be to help the entire S3OK program understand how wicked problems are understood in Oklahoma. What is it that people are facing? Why are these problems being fit into narratives that are in conflict with one another? The second is to provide feedback and pushback where necessary on the direction and the potential value of the research investment that we're making in this project. As I said before, each year we will be re-evaluating how we're funding the different programs. We have a special category of funding, we call it seed funding, that's intended to augment the most promising directions in the program. And OLAN will be helping us understand how to make better use of those funds. Third, the OLAN will help us integrate the science that we're producing into a strategic direction for Oklahoma. Investments in water and carbon and infrastructure policy in the state. And finally, the OLAN will help us in writing the strategic plan upon completion of the project. So how will OLAN members do this? Well, first, they'll serve as an active participant in the interactive process over 5 years.
Hank, you have 1 minute to finish up, please.
I'm just about done.
Okay.
The OLAN will be reviewing periodic short research updates and respond a couple of times a year in survey format to how they think the problems are evolving and what prospective solutions look like. We want them to self-nominate or nominate others to be members of what we call the targeted group in OLAN. These would be people who would be willing to participate in a more engaged way, who would attend the annual academies each year, though every member would be invited to participate. So in summary, we're focusing on these wicked problems to understand how human dynamics and natural systems drive the critical problems facing Oklahoma today. And we're looking for an OLAN to collaborate with our science teams to strengthen that understanding, push boundaries for creative solutions to some of these problems, and create a visible test bed, an example for how these kinds of problems can be addressed in the future.